All right, here you go, ladies and gentlemen. It is the week 14 test. So let's go through this. And remember, you're matching this up against your own test. So you're probably watching this Monday afternoon, Monday night, getting ready for Tuesday's test. It's part of your studying, part of your preparation. And as you watch it, be looking at your own test and see which things you did well. So you make sure you do those again on Tuesday's test, and which things you need to work on. And remember, both week 14 concepts, so 14-1A, and week 13 concepts will show up on the week 15 test. That's the great thing about this program. As it cycles around, it gives you lots of chances. So let's jump to it. So problem 1 is an evaluation problem. And we're going to substitute in. That's our first step. So where we see 5x, since x equals 4, we know that means 5 times 4. Anytime you see a letter and a number next to each other, the number's called a constant, the letter's called a variable, that always indicates multiplication. So we have 5 times 4 minus 7 equal to t. T is right here. T equals 3. So that means we have 3 squared plus 4. 3 squared, right here, let's just remind ourselves, 3 squared means 3 times 3. Not 3 times 2, 3 times 3. Gives us a total of 9. So the left side of this, 5 times 4 is 20, minus 7. 20 minus 7 is 13. And the right-hand side of this, 3 squared, that means 3 times 3 is 9. 9 plus 4 is also 13. And since our final is that it's 13 and 13, we circle A. We know this is a true statement. 5x minus 7 equals t squared plus 4 when x is 4 and t is 3. That's the way we think about that. All right, on to the next problem. So we have x cubed. That means when you see x cubed, that means x times x times x. So in this case, since x is 4, that means 4 to the third power. So we have our 4. Remember, I talked about putting that in parentheses, so if it was a negative, you'd be sure to make the negative times the negative times the negative. So we have 4 to the third power divided by 2. Well, 4 to the third power is 64, so we have 64 divided by 2, and 64 divided by 2 is 32. We'll use the space down below. That is equal to 12t, which means 12 times 3 plus 2, and 12 times 3 is 36 plus 2, so we're saying that is equal to 38. And you know for a fact that 32 is not equal to 38. So we use, let me do it again because I kind of messed it up there. We use this sign, which we read as not equal to. 32 is not equal to 38. So this, the idea that that's equal, that's a false statement. So B is false. Letter C, 7t. So again, we look at t is equal to 3. 7 times 3 plus x plus 4 equal to 7 times x, 4, minus t, so minus 3. So since I got the blue pen out, let me just finish this side. 7 times 4 is 28, minus 3. 28 minus 3 is 25. 7 times 3, back on the left side, the green side. 7 times 3 is 21 plus 4 is also 25. This is true. Whether you wrote true or you circled C, that one is true. So review those, because again, you're going to see this kind of work on the next test. Plus, this is an important concept to understand moving forward. This isn't just about passing a test, but this is one of those fundamental ideas that we use in algebra. All right, on to number 2. So on number 2, we have a rectangle. Here's my rectangle. And that rectangle, I'm just going to smooth out that side of my rectangle right there. That rectangle has a length and a width. You know that. You know that rectangles have length and width. In fact, I'm going to label all the way around, length and width. So we know that finding the perimeter for a rectangle can be described by that expression. And we need to know the value of L and the value of W. And they tell us that. They tell us a length of 24. So L is equal to 24. And a width of 18. W is equal to 18. So now if we take the information, the length 24, the width 18, and we substitute it in, we get 2 times 24 plus 2 times 18. 2 times 24 is 48. 2 times 18 is 36. 48 and 36 is 84 meters. And that is our answer. 84 meters is the answer to the question, what's the perimeter of this rectangle when the length is 24 and the width is 18? All right. Moving on down to All right, problem number 3. So Sarah makes a claim. Sarah claims that when 2/3 is divided by a fraction, the result will always be greater than 2/3. So the claim Sarah's making is this. You multiply 2/3 times a fraction, and your answer is going to be bigger than what you started with. It's going to be bigger than the 2/3 you began with. You're asked to do 2 things in this problem. You're asked to create an expression that supports Sarah's claim. That means makes Sarah's claim true. So you're going to find an expression that makes her claim true. The second thing you're asked to do is write an expression that contradicts Sarah's claim. So you're going to do something that proves Sarah's claim false. Not Sarah's clam, Sarah's claim false. So let's go to the one that makes it true. We're going to divide by something that will give us a number, an answer, greater than 2/3. Think about what happens when we do division of fractions. When we do division of fractions, we actually multiply. We take that 2/3 that we started with, and we multiply by the reciprocal of this division. Something we should remember from our previous work is that to get a number greater than you start with, you have to multiply by something bigger than 1. If you multiply by 1, you get what you started with. You've known that since probably, I don't know, 3rd grade. 2 times 1 is 2. 3 times 1 is 3. If I want to get bigger than 3, I have to do something like 3 times 2 to get 6, which is bigger than the 3, or 3 times 4 to get 12, which is bigger than the 3. But if I multiply by less than 1, let's take 4 times 1/2. Well, we're saying what's half of 4? That's 2. That gets smaller. So I'm going to need a fraction greater than 1 whole in this multiplication. When I get to this point right here, if I want something greater than 2/3, I have to multiply by a fraction bigger than 1. I could multiply by 4/3, for example. multiply by 4/3, and when I carry that multiplication out, I get 2/3 times 4/3 is 8/9, and I know 8/9 is greater than 2/3 because I can turn them both into ninths. I can keep the 8/9 as 8/9, and I can make the 2/3 into ninths. So 3 times 3 makes 9, 2 times 3 makes 6. 8/9 is greater than 6/9. So now you're saying, well, that's great, so you've multiplied by this thing bigger, but that's not what it asks me. It asks me about this division. You're absolutely right. So think about what happens to this number now when it started as division. Remember, we're multiplying by the reciprocal. So the reciprocal of 4/3 is 3/4. That fits in 3/4. 2/3 divided by 3/4 becomes 2/3 times 4/3, and that 4/3 fits into this thing back up here that we learned in grade school. Let's get rid of that first part right there. Here's the idea again, multiplying by more than 1. So your answer to this first question, to question A, is anything less than 1. Anything less than 1 whole. Any fraction less than a whole in division will become a fraction greater than a whole in multiplication, and that will end up with an answer bigger than what you started with. So now we're going to contradict Sarah's claim. Well, if anything less than 1 whole ends up with a number greater than you started, anything greater than 1 whole will give us a contradiction to Sarah. Will give us an answer that's smaller. Let's just pick 2/1. All right, so I've got 2/1. So I have 2/3 when I change this to a multiplication problem times 1/2. I could cross cancel, but this is going to be fast enough without. Gives me 2/6. Gives me 1/3. 2/3, what I started with, is greater than the 1/3 I finished with. Or to keep it in the same order that we did last time, let's do it this way. The 1/3 I finished with was less than the 2/3 I started with, and that makes Sarah's claim false. Her claim is it'll be greater than. I just showed you it's going to be less than. So this is one of those cases where you're going to use a combination of the logic that you've built up from your work in 3rd grade and 4th grade and 5th grade and 6th grade and so on, and this idea of working backwards. Figure out what you would need to get that number that's greater in multiplication, and then division will just be by its reciprocal. On to number 4. So in problem 4, we've got temperatures. And here's something we talked about in class. They want to know what is the change in each of these. What's the change? So change is always equal to where you finish minus where you start. And that is true whether you're talking about the change in the amount of money you have. Your amount of money in the bank is the difference between where it is now and where it was when you started the account or started the month. Your change in time is the difference between the time right now and the time when you started something. So it's no different here. This is going to be the same situation. The change is going to be the difference between where you finish. At 10 a.m. it is -1 degree, and at 6 a.m. it is negative 15 degrees. And negative 1 minus negative 15 is equal to negative 1 plus positive 15. Remember, subtracting a negative is like adding a positive. This is our integer work. And that gives you 14. And 14 degrees is the change between 6 and 10. Between 6 and 3, same idea. At 6 o'clock, it is negative 15 degrees. At 3 o'clock, it is positive 7 degrees. The 7 is where you finished. Take away the negative 15 where you started. That's the same as 7 plus 15, and that's going to be a change of 22 degrees. Okay, to the back of the test. Now, this is the one that seemed really big, but you can do these problems. So let's jump down and we'll do each of them individually. Letter A. So in letter A, the way that I would solve this problem, the way I'd suggest you solve this problem, is to take the 9 1/8 and make it into 8. So I'm splitting the 9 now. Let me do this off on the side, way over here. I'll do it right down here. So here's what I'm going to do. I'm going to take the 9 and I'm going to change it to an 8 and an 8/8. Basically 8 plus 1. We know 8 plus 1 is the same as 9. Why am I making my 1 in 8ths? Because that's what we're working in is 8ths. So when I take this 9 1/8 and make it into 8 and 8/8 plus the 1/8 that's already there, I'm going to have 8 plus 8/8, that's just the 9, plus 1 more 8th. That gives me 8 and 9/8. And I can subtract 2 and 3/8 from that. Now I've got enough 8s to take away. 8 minus 2 is 6. 9 minus 3 is also 6, so 6/8, which simplifies to 6 and 3/4. So letter A, let's scroll up for a minute. Letter A is 6 and 3/4. 6 and 3/4 is right there. That's the 6 and 6/8. But we need the 6 and 3/4 for the bottom to simplify. Now, the other way that this problem could be solved, the second way to solve this problem, is to take and convert everything into improper fractions. So 9 1/8 becomes 73 over 8. 9 times 8 is 72 plus 1 is 73. In 9, there are 72/8 plus you have 1 more 8. 2 times 8 is 16 and 3 makes 19. So we have 19/8 for the second part. If you do 73 take away 19, you get 54. So you have 54/8. 8 goes into 54 6 full times with 6 left over, so 6 and 6/8, which is my same 6 and 3/4. So you'll notice, let me scroll so you can see both. You're going to get the same answer either way. It just depends on how you like to solve it. I personally like to solve it by doing the borrowing or the regrouping. But if you prefer the improper fraction method, as long as you understand what you're doing, either one's going to give you the same answer. All right, letter B. 5 1/2 minus 1 3/4. Well, we know, first rule about adding fractions, common denominators. So here the common denominator is going to be 4. So we're going to have 5 2/4. That's what 5 1/2 looks like as fourths, plus 1 3/4. Now that we have everything in fourths, we can add the 5 and the 1, we get 6. Add the 2 and the 3, we get 5. So we have 6 5/4. We can't leave an improper fraction in our mixed fraction. So 5/4 is the same as 1. Let me just write it right here. 5/4 is the same as 1 1/4. So I already had 6, so the 6 and the 1 is a 7 and 1/4. That is our answer for letter B, 7 1/4. and 7 1/4 would be right there. 7 1/4. It's also the same as 7 2/8. This is all being counted in eighths. Just like our letter A, excuse me for the frog in my throat there. Just like our letter A was 6 3/4, which is the same as 6 6/8. Letter C. 7 7/8 minus 3/12. So we need a common denominator. First rule, have to have a common denominator. Here it's going to be 24. That's the smallest number that 8 and 12 can both go into. So we're going to have 7 and some amount of 24ths minus some amount of 24ths. Well, 8 times 3 makes 24. So this is going to be 7 times 3, or 21 24ths. And 12 times 2 makes 24, so this is going to be 6 times 2, which is, or excuse me, 3 times 2, which is 6, so 6 24ths. So the 7, there's no whole number here, so we have 7 comes across. 21 take away 6 is 15 24ths. 3 can go into both 15 and 24. 3 goes into 15 5 times. 3 goes into 24 8 times. Our answer, 7 5/8. And that is right out here on our number line, 7 5/8. Finally, letter D. Again, common denominator for 5 and 3, it's going to be 15. So we're going to have 2 and some amount of 15ths plus 3 and some amount of 15ths. So we ask ourselves, 4 fifths, what does that equal in 15ths? Well, this is 5 times 3 to get 15, so this is 4 times 3 gives us 12 right there. Same thing with the 2/3. I've got, let me just change up colors here. I've got 2/3 into some number of 15ths. 5 times 3 is 15, so 5 times 2 is 10. So now we have 5, the 3 plus the 2, 5. 12 and 10 is 22 15ths. 22 15ths is an improper fraction. It is equal to 1 and 7 15ths. So the 5 and the 1 make 6 and 7 15ths. And that is our answer. 6 and 7 15ths is our answer, and that's where it's located. It's located, this would be, think of our eighths, this spot right here is 6 1/2, which is 6 and 7 14ths. 7 15ths is going to be one spot past that. Right there is going to be our 6 and 7 15ths, just a little less than 6 1/2. All right, let's close it out with the bottom. This has been kind of a long video, but hopefully you've gotten a lot out of it. The question is, which of the following expressions is less than? Which of the following? All right, so let's do each of these. 3a, A is 9, minus 5b, b is 2. 3 times 9 is 27. 27 minus 10 is 17. We are looking for things that are less than 15. 17 is not less than 15. For the next one, x squared, where x is 4, so 4 squared plus 7 is 16 plus 7, 23, also not less than 15. Letter C, 2 times x, they tell us x is 3 in this problem, plus 8 times y, which is 4, gives us 6 plus 32 gives us 36. Also not less than 15. D better work out for us or we'll have none of these. And that can't be possible. A to the third power. So we have 3 to the third power minus 15. Well, 3 to the third. Let's go right here a second. 3 to the third is 3 times 3 times 3, which is 27. 3 times 3 is 9 times 3 more. So 27 minus 15 is 12. Yay, D is our answer. All right. So rewatch the sections of this you need to rewatch. You're not going to see the week 12 problem. This fraction problem is done. We're not going to see that again. However, you can always come back and take an intervention test on that. So don't treat it like you're totally done. If you're understanding it more and your grade isn't great on that topic right now, talk to me about an intervention test. You will see the 13 and the 14 on this next test, so be prepared for those. And as always, if you have questions, bring them to class.